Broadcast is now starting. All attendees are in listen-only mode.
Good morning, and thanks for joining the revised time for our webinar looking at how you can make Zero Trust work. I thank you very much for your time this morning and dialing in again, and apologise for the technical issues that we had with Citrix last week. My name is Shona Bradshaw. I'm the Marketing Manager at Bytes Security Partnerships. I'm delighted to be joined today by Ian Perry, who is one of the cloud specialists and Zero Trust specialists at Zscaler, who's going to be taking you through the bulk of today's presentation. So a little bit of agenda for today. So I'll do a very short, brief housekeeping in terms of how the webinar is going to work this morning. Brief introduction to Bytes. I will keep it brief because many of you do know us already, and before introducing Ian. Then Ian will be taking you through some of the reasons that organisations are looking to adopt a Zero Trust model and the benefits that that can bring to them, before getting into the nitty-gritty of how that can be done in a way that balances the need for strong security with user convenience, before finishing off with a demonstration of their solution, Zscaler Private Access, which is one of the routes that customers and businesses can take to achieve that Zero Trust user convenient model. We will have a Q&A at the end as well. So housekeeping for today's session. Attendee lines are on mute throughout the presentation, but please do post questions via the questions or the chat box. We'll monitor those throughout the session so that I can pose those to Ian at the end. I'll come on and do an interactive Q&A at the end. We will, for the purposes of today's session, not be getting into commercials or financials on any solutions. Of course, those questions and those discussions are more than welcome via your Bytes account manager. We will be keeping the topic today to strategy and solutions. We are recording today's session, so we'll make the recording available to you and your teams post-session. And lastly, a quick request from me. We do have a feedback survey at the end, so if you could take just a minute, it's a short 5-question survey to give us some feedback in terms of the content of today, that would be great. So without further ado, who are Bytes? So Bytes Security Partnerships are the security specialist reseller within the Bytes Group in the UK. And what we really aim to offer is to marry up the agility and the insight and the personal approach you would expect from the smallest specialist partner with the scale and the scope that comes from being part of a much larger group. We're exceptionally proud at Bytes Security Partnerships of the technical expertise that we offer around the solutions that we deploy and we recommend to the marketplace. And that allows us to enjoy top-tier vendor partnerships, which means that we deliver for customers on both the technical side and also the commercial value side. We work across the full spectrum of information security, from the standard perimeter security, next generation firewall and endpoint security, through to cloud, mobile security, data security, access and authentication. So across the full spectrum of the security suite, offering both hardware and software solutions. And what we really offer, where we add value to businesses and to our vendor partner solutions, is via the technical suite of services that we are in a good position to deploy. So whether that's looking at security strategy development, technology mapping, project scoping, planning and delivery, or 24/7 direct-to-engineer support, there's a myriad of ways in which we can act as an extension of your IT teams to make sure that the solutions you deploy add value very quickly. That's more than enough about us. Why are we talking to businesses today and looking at Zero Trust? Now, there's an acceptance in the marketplace, really, that this castle and moat approach, this traditional perimeter approach to security, is not preventing breaches. At the same time, corporate data centers also don't serve a contained, controlled network of systems anymore due to more remote users, their expectations of being able to connect from any device, from any location, and also the business's expectation and desire to exploit cloud technologies in order to make the business increasingly flexible and more competitive. Zero Trust, at the same time, offers businesses a way of getting a more granular and a better perimeter enforcement that takes into account diverse users, their locations and other data. And what Ian's going to be running you through today is how can you actually adopt a zero trust model, which should be inherently more secure, without sacrificing user experience, because user expectations, given the consumerization of IT, have never been higher. So that's really what I'm going to be passing over to Ian to discuss, ways and strategies that you can adopt a zero trust model without adversely affecting the experience of your users or the flexibility and competitiveness of your businesses. So without further ado, I'm going to introduce Ian. So he is one of the emerging technology engineers at Zscaler, looking after the UK and Ireland. Zscaler themselves we've been working with for some years as a top-tier partner, and they're a real pioneer in leading the way in cloud-first security, particularly on the website. They're a specialist in security as a service, and they protect a myriad of organizations worldwide. So they really are the best partner for us to invite to talk to you today around models for zero trust and some of the solutions that they have that they can enable you to think about zero trust in a more in a different way, and perhaps a more useful way for your businesses. So without further ado, I'm just going to hand over to Ian, and he'll be taking you through looking at zero trust and looking at how Zscaler specifically can assist in a positive and effective zero trust model. Over to Ian.
Thank you very much indeed for that introduction. So good morning, everyone. My intention today essentially is to walk through the concept of zero trust, not just from a Zscaler perspective, but also from a wider context of the market and some of the trends that we're seeing within that move towards zero trust. In doing so, I hope I can explain some of the key concepts, some of the key integrations, but also explain what it actually means to deploy these kinds of solutions and the impact on two particular specific areas that I think are of value. The first of which I think is the user experience and the concept of low impact but high value delivery of application services across the concept of a zero trust framework. The second piece, which is equally important, is the ability for us to manage from an operations perspective what business processes and business policies can be deployed by leveraging this kind of solution. So in other words, maybe streamlining to a certain extent some of the internal change control processes and providing a degree of orchestration, stroke automation around the way in which you expose applications to a user base, regardless of whether they're inside your organization or external. So fundamentally, the sort of starting point here in terms of the access to those applications is the concept of the darknet. So without really over or belaboring this point too far, the concept of the darknet, not to be confused with the dark web, we're not talking about Bitcoin and sort of transacting dodgy deals here necessarily, but the concept of the darknet, was to enable people to access resources within that network without actually having been given any context around what those resources were. In other words, effectively divorcing network access and instead driving an identity-driven model. So what that effectively meant was that these networks did not operate in a traditional model that you see today. Access mechanisms, identity, and policy are in fact something that occur within the core of the solution as opposed to being exposed to the user. So what we're talking about today essentially in terms of zero trust is decoupling traditional models of network access and then in doing so, providing a brokering mechanism, what we call a software-defined perimeter effectively, between those two components. So as I go through the presentation, I will again break this down based on user experience, and I will break it down based on the operational parameters and considerations of how the solution is deployed. Now, from a user experience perspective, what this means is you don't need, as a user, to understand where the thing that you're leveraging exists. In other words, I'm not sitting here on my device at the moment thinking, oh, I need to connect to a VPN to get to something in Azure. I'm not saying I need to connect to another VPN to get to a resource that's in another location necessarily, effectively giving me the freedom to consume those applications without the need for any specific access mechanism. Likewise, from an operations perspective, I'm trying to devolve that policy control into the organization so we can make faster decisions. So what exactly are we saying here? So your apps without the network. So the concept here is there's no more chewy centers. So Shona in the initial introduction there referred to the concept of perimeter. Now, perimeter, as far as we were concerned for the last, say, 20 years or so, we've been building these mechanisms where we bring people inside the organization, we look at their access, followed by some degree of security. And consequently, the networks that we've built were designed from the inside out. So in other words, what we're going to do is we'll verify what you're doing, but we're never going to establish a trust model. The concept is that once you've effectively done something, then I think I know who you are. I then decide and determine the access control based on that. So in a traditional model, that might mean I've posture checked a device, I've brought you into the network, you're on this IP address, now you can do something. And likewise, all resources in that mode are accessed in a secure manner regardless of location. So we're trying to move from me needing to know where you are to needing to know what you're trying to do and inspect and log all of that traffic. So no more of the organically grown remote access solutions where 3 years down the line you're looking at an access control list and going, okay, I wonder why we made that change. So this really does fundamentally, if you like, change the model. So the original concept of zero trust hasn't actually changed in 8 years. So essentially what it's saying is it's built to connect users to the network, not to limit connectivity to applications. So in other words, what I'm saying here is it's basically bring you inside the organization and from that point onwards determine what you're allowed to do. And if you think about that in terms of any IPsec type connectivity, any client you might be running, that's fundamentally what it's doing in the background, even if you configure it to be always on, which has its whole other sets of interesting discussions ranging from battery life on mobile devices right the way through the whole gambit of network connectivity from a compromised device. If you look at what the Internet of today does, just to give you some idea here, essentially what we do is we enable you to perform a number of different actions. So the first thing we do is we leverage these same planes of control and data. So I'm going to access something, that's my connection, and in doing so, I'm then going to provide a degree of authentication. So we do employ identity in these environments, okay? And that is something, again, from a directory services perspective and from literally the expectation of logging into applications or centralized SSO around things like Office 365, we understand that environment. And then what I'm doing is I'm saying, okay, here's the data, effectively. And what you see in that model is what is almost certainly a traditional model of access that we see in Zero Trust. Now, essentially, if you look at that from an analogous perspective, I've just brought Ian inside the organization and I can see everything. If I'm standing on the high street, I can literally see all the different buildings, all the different resources that are required, subject to my network access. And fundamentally, in a world where we're extending identity and the single sign-on mechanisms to these workloads, and indeed wherever these workloads live, that's not necessarily a very, shall we say, conducive way forward to manage access to these core applications and the crown jewels, if you like, of the organization going forward. So essentially, something in this world has to change, and it has to change for a number of different reasons. And if I had to pick the top 2 or 3, I'd say the first one is user identity is no longer linked to the device you're accessing from. So the concept now of saying, I have a mobile user, I have a remote user, I have an in-corporate user, for example, we don't really. Ian can be all 3 of those things at different points in time. So from that perspective, actually what I have is a user called Ian that I want to treat differently in certain circumstances. The second thing I think that comes into play here is effectively the resources that I'm consuming. So in the model I just described with that main street, if all my applications happen to live within a core data center within my organization, then that could be, to a certain extent, a valid way of approaching this problem. But as soon as I start to move workloads into the likes of AWS, Google Cloud, Azure, and that becomes distributed, which we increasingly see as a component part of the challenge to the security practice within a business, because digital transformation is about digital transformation in these environments, not just changing applications, then again, this model challenges that aspect. And the third thing is the feedback loop of reporting and management. As I said at the very beginning of the presentation, the concept around operations management within Zero Trust is a live fire exercise. You can actually see what people are doing and track them effectively across the solution. Whereas in the old world, you couldn't do that. So, to introduce you to the concept of what we call the software-defined perimeter. So the software-defined perimeter is a modern approach to application access and incorporates Zero Trust. So when we're talking about the structure of Zero Trust and the concept of that, that can extend into another number of areas of security, as I think was briefly alluded to in the introduction. What I'm talking about here is the remote access leverage of zero trust in order to provide that application access. So there's a number of different things this achieves. The first one does is it removes a network-centric design. So if I'm exposing applications across different areas of the internet or different cloud platforms, I don't worry about building a network. I effectively leverage public infrastructure such as internet or other access mechanisms to do this. So the first thing we do is we're decoupling private application access from network. I'm not giving you IP access, I'm giving you another form of access. This is 100% software defined, so there's no physical or virtual appliances. If you think of it in the old world, I go out and I build remote access for a solution. I'd be having conversations about things like concurrency of users, what's the bandwidth allocation for this location, where do I expect my users to connect. None of that traditional dimensioning works with a software-defined perimeter because it's all handled within the cloud service. Application access is micro-segmented. So literally what I mean by that is, instead of me giving you IP to IP connectivity over which you run all of your applications and then I try and control you, I'm actually building an individual path across this solution and brokering it for each individual application. So that might mean, for example, an RDP session, it might be an intranet access, it could be a number of different applications that could be employed at that point. The last bit then is around the advanced visibility. I think I sort of alluded to that earlier. I can give you a full end-to-end path of how exactly that might work, but it is a different approach in terms of zero trust of firewalls in terms of users being placed on the network. So Gartner have observations around how we see this entire world moving. Generally, I think the drivers around cloud adoption, mobility, and those other pieces that we've looked at and evidently consumed for some years now are the key drivers. So let's look at what this looks like when you move into the software-defined perimeter. If you remember 2-3 slides before this, we looked at a traditional control mechanism. So this is what the software-defined perimeter actually does. So the first thing I do is I establish trust, because in order for me to understand who this person is, what permissions they have, and determine what I want to allow them to do, I'm going to establish that trust mechanism. And that trust mechanism is extended end to end. So in other words, the software-defined perimeter is establishing a trust basis for any connectivity from that user. So if you look at 2 or 3 things I said earlier on, so number 1, a user can be any kind of user, that's established by trust. A user can be anywhere, that's established by the trust. So in other words, your location isn't important, but who you are and the trust relationship with your resources becomes the key sort of criteria. The next thing we do then is we provide the authentication. So we will federate in some way, shape or form, so I'm running ahead, to how you derive that identity. So I've established a trust mechanism end-to-end to give access. Now I'm going to determine who you are. So in the case of an SDP or software-defined perimeter, you're going to consume a directory, whether that's Azure AD, Okta, Ping, or varieties of those in our case from a SAML IDP perspective. Having authenticated, I'm then going to manage the connection. So now you're seeing an in-connection and then an encrypted mechanism afterwards. So the key differentiation here is, number 1, I'm not giving you a network access. I'm establishing trust followed by authentication. The data that's transferred is encrypted and the connection is determined by the authentication and trust. So there is no concept of the sort of more open methodology that we looked at earlier on. Then finally, you start to see the data flow within each of these encrypted capabilities. So nothing is exposed to the outside world. You determine the identity that is then leveraged by the trust as an organization. So it's fundamentally a different way of looking at doing this. What that means, if you look at it from an analogous perspective, is in this case, Ian, having established trust with the solution and then having been authenticated as Ian Perry, for example, at zscaler.com, I am then in a situation where you can determine which of the resources within your organization you can actually see. So there's no main street. There are simply the doors that I can walk through that give me access to the applications that are derived by your organizational policy. That is one of the key differentiators here. A third-party access person can only see consoles to manage a solution. A generic user within an organization can see intranet and other core resources. Someone in finance can have enforced multi-factor authentication and see the financial applications, all of which, remember, is being reported on whilst it's being accessed. So what does that mean in terms of our solution? Let's talk a little bit about Zscaler private access and try and understand a bit more around the meat on the bone, so to speak. So first of all, let's break it down into those different components. So we looked at the client side. So generally, client is going to be connected to the internet, so it's a coffee shop type model. We don't have any specific knowledge of the corporate ecosystem, and we're an untrusted device. What I mean to say is, as I said earlier on, you can have people with multiple devices. They could be corporate owned, uncorporate owned, and there are a series of different sort of nuances around the way in which that can be employed as well. If you look at the transport and path, we're looking at an always on model. In other words, what I'm not doing here is asking you to necessarily connect to a service. It's always available, I think is probably a better way of describing this. The traffic is indistinguishable from any other content. In other words, you're not leveraging a particular route to gain access to it. And you're also leveraging existing connectivity. In other words, there's no new paths involved. When you look at the application level, okay, there is no soft center. We're isolating applications from the network, and the network segmentation, if you like, is actually baked into the solution. So the segmentation piece is quite important here. If you think of it in a traditional data center model, I might be talking about software-defined perimeter. There might be a number of mechanisms employed like private VLANs, VRFs, or routing mechanisms to segment that application traffic. This is actual individual segmentation of the application, not just in terms of going into one location, but across the platform. So I could segment an application into AWS, I can have another application connected concurrently to Azure, another connected to platform as a service, another one connected to your private data center. One user from a single interface, their device consuming all four of those paths ubiquitously. So again, it's a very, very different way of looking at this. So if we break that down from a Zscaler perspective, so first and foremost, we remain in the coffee shop from the client side, we remain off the network, there's no network connectivity, and although we're untrusted at the network, we can request applications via the TLS tunnel. So what I'm saying there effectively is, you don't need to worry about where I am, because I'm going to manage that trust model that we described for the application access across the entire solution. The second thing you'll see then is, effectively from our perspective, we're only accepting authorized connectivity. So we've established the trust and the identity. We approve or reject the application access based on your configured policy. And we bring the application to the user rather than the user to the application. The distinction being, if I'm sat on this device at the client side, I can't see anything of the application environment at all. Everything within that microsegmentation is controlled. And last but not least, and this is one of the critical components of the software-defined perimeter, no inbound access to this. The connector that we place in that application environment connects outbound to the cloud. So the base rule set that you need to expose an application in a location is outbound 443 for the TLS connection. That's it. So there's no access without authorization, and you can isolate and segment according to your requirements as an organization. So just to think about that for two reasons very briefly before I move on. Let's say, for example, you're migrating an application to AWS, you're migrating an application to any platform indeed. This is precisely the kind of mechanism that can be employed to do so, because the user accesses the application, you determine from the connector's perspective where that application resides. And that gives you very much high degree of operational control. So if you look at the ecosystem effectively, there are a number of different pieces that fit together to make this work. And I think it's important to recognize where software-defined perimeter sort of sits in and or augments those particular solutions. So the first thing we're doing, we're very, very popular in this regard with people consuming cloud providers and cloud access. So private access, anywhere that you would normally, in a traditional model, have placed a user into that network, is what Zscaler private access is designed to remove and then augment. So as a distinction, if you're consuming Office 365, we see that as an internet-facing service as opposed to a private application. The second thing we do is we integrate with any SAML 2.0 shibboleth-based IDP. So Okta, Microsoft are two that we've mentioned here, but you could also say ForgeRock, Ping, or a number of other different vendors that we have those integrations with. So again, ADFS, for example, relatively straightforward to gain access to that identity, but it is a critical feature of the solution, because if I've got the trust, I can't do anything without the authentication around the microsegmentation. Reporting and analytics, the third piece on the side there, really important, because in order for me to make use of this information we're deriving from the application access, I want to be able to consume that somewhere else. That's already built into the solution. And likewise, we have a concept of integrations with Microsoft around Intune, for example, AirWatch, other providers of MDM functionality, and posture checking as well. So if you look at that as a sort of the ecosystem that exists around this software-defined perimeter, two things hopefully become apparent. The first one of which is this is an access mechanism, and the second one of which is that it is designed to be ubiquitous across both the connecting device and the environment in which you consume the application. So effectively, what we do is we define based on 4 criteria effectively. So number 1, we provide application access to the network without the use of a VPN. So in other words, that IP to IP connectivity is removed. We never reveal applications to anyone that isn't unauthorized, and an application for us is any TCP, UDP, client server application. So again, the whole gambit. We could be talking, I don't know, SAP, SSH, not Telnet necessarily, but right the way through web applications as well. The application segmentation is done without any degree of network segmentation, and that's really critical to the deployment of this solution. Because what I'm not asking you to do is change your architecture. I'm asking you to change the secure remote access mechanism by adopting that zero trust approach. So one of the key things around the ZPA solution is that we're able to install and migrate very cleanly from an existing remote access solution into these environments and leverage the capability going forward. And the last bit here really is the internet becomes the new secure network. So we started talking about the internet without a VPN, etc., etc. But as I alluded to at the beginning of the presentation, one of the advantages here is that the software-defined perimeter is always available, but it's not always on. So consequently, several things come out of this. Number 1, your network layer access is again ubiquitous. So I can sit in a corporate location, I can pick my laptop out, I can walk out into my car tether, and the user doesn't have to change any configuration. The VPN, as in what we're describing here, the software-defined perimeter solution, retains its integrity across that change. And the second thing is it doesn't utilize resources unnecessarily. So I'm not sitting there with constant keep alives or connectivity running in the background, which has that implication on, should we say, battery life and others. So private access to private applications. So the first thing is there's no concept of firewall appliances or ACLs, which reduces or minimizes overheads and costs. So what I'm suggesting here is because I'm not advertising any inbound traffic into my cloud platform or into my data center, I can either reduce the rule sets and the complexity of my infrastructure, potentially removing, in a number of cases, depending on levels of adoption, any of that inbound stack. So I don't need necessarily DDoS protection. I don't need a firewall sitting there because everything is outbound connectivity from the connector. Application segment without network segmentation enables me to more easily satisfy things like PCI compliance requirements and or regionalization of applications and data without complex network configuration. So for example, my German users can only consume applications in Germany. My UK government users can only consume applications in UK government locations. So you can be very granular in the way that you expose these applications. The next thing we're doing is application connectivity without trusting the users and placing them anywhere in your infrastructure. So think of it this way. Because I haven't given you network access as a user, and because I'm managing that access more cleanly, things like NotPetya, WannaCry, for example, using things like WinC drivers, and then leveraging network connectivity to propagate, do not affect this solution because there is no concept of any network connectivity between the user and the target environment. And the fine thing here is really very important around the user experience. As I said at the very beginning, in a more modern world, we don't expect the user to understand where any of these resources reside. So let me give you a practical example here. Let's say, for example, I have my intranet site running in a private data center. And during that week, we decide we're going to move that intranet application across to an AWS workload and spin up an AMI to run that workload. Fundamentally, from the user's perspective in this environment, nothing changes. They didn't know where it resided in the first place. You can consequently then migrate or manage application access much more cleanly in that regard. So, just moving into a little bit more detail around what the solution does. There are 3 components to ZPA. I'll just give you a quick overview of each of them, and then I'll talk you through what a user's application access looks like. So at the bottom of your screen there, you can see what looks like a laptop and various mobile devices. They would leverage what we call our Zscaler app. So ZApp is a lightweight application that sits on any of those devices and enables you to consume the ZPA service. So ZApp's view of the world in this regard is very straightforward. It understands the IDP, so it interacts with Azure AD or whichever IDP you currently have. It understands how to build the outbound tunnel, the pinned TLS tunnel, to our ZPA Zen, which is the cloud service that you're connecting to, and it understands what constitutes a private application. In other words, from the perspective of company.com, what are the internal applications that I want to expose to you based on your authentication? The second component is probably the more critical one, and based on what we've discussed so far. At the top of your screen here is the ZPA connector. So the connector is, again, a lightweight appliance, that sits inside any of these environments that you want to expose applications and instantiate their access. So that might, for example, be, I don't know, a CentOS RPM, it could be an AMI in Azure, it could be a AMI in AWS, a workload in Azure, etc., etc. Most of that configuration is done. Now, the connector's view of the world is it consumes internal and external DNS. In other words, it can resolve the cloud and get to our service, and it can resolve the internal application that you want to access via FQDN. So, for example, intranet.company.com. It has an IP address in that environment, and it can make an outbound pinned TLS connection to the ZPA Zen. So again, two things I said there that are very important to understand. In the traditional model of VPN access, I build concentrators and I dimension them. In this world, this is a lightweight, cattle not pets approach, so to speak, to the connector. So building one takes less than 5 minutes and can be automated for auto scaling in AWS, for example. So literally you can scale up or down your access requirements within a given location very easily. The second most important thing is, because it's only ever outbound access, nothing of the internals of your data center environment is exposed to the outside world. There are no inbound listening ports. There's no DNS resolution into that environment. You are literally dark to the outside world. So going back to the dark net sort of discussion we had at the very beginning, the application is dark on the client device prior to authentication and policy. The environment that you're consuming the application, again, is dark to the outside world in its entirety. Which brings me neatly to the third component in the middle of your screen. So the ZPA Zen is effectively the brokering mechanism that enables all of this connectivity to take place. The Zen consumes your IDP via a service provider SAML relationship, so that I actually know who it is that's doing what, so I can apply policy on those identities. The second thing it does is it applies that policy. So in other words, for example, excuse the background noise, I may have user A requires multi-factor authentication, user B is in Germany and can only access German resources, for example. And the third thing it does is availability. So you consume ZPA as a service. In other words, what I'm suggesting here is your application access is automatically load balanced, both in terms of return path, speed of access, and location automatically by this solution. So let's say, for example, I had the same application running in two environments. I have a user in Japan attempting to access it. There may be an optimal path to a Japan data center through our service. Likewise for UK or European access. So the concept here is you can traffic manage anything that you need to across the solution going forward, and based on that particular level of access. So, sorry, I beg your pardon, I got a bit distracted there. So what a user's access to an application looks like is this in its base form. So user sits on their device, they enroll in the service. I then attempt to access intranet.com, for example, because I've got that bookmarked, or I try and access my SAP thick client application and I fire it up on my desktop. So remember, at this point, I'm enrolled in the service. I haven't connected to a VPN. I don't know what I'm connecting to. I'm literally just firing up my application. What happens in the background is ZApp intercepts the DNS request. I then go to the ZPA Zen. I say, does Ian have the policy to view these particular applications? And if the answer is yes, what I then do is I go out to each of the connectors within your tenant and I say, which of you can resolve that application at that point in time? So let's say, for example, in this case, it's the top right-hand data center up the top there. What then happens is I build a byte stream between those two components and I allow the user to gain access to that application. So two really important points. Number one, the user hasn't changed the way that they work. They just access the application. You have operationally determined where that application lives, and you've provided a clean, microsegmented path to that application for that access to take place. So let's just look at the acid test here. So what happens then if I move intranet.company.com from the top right-hand side data center there, and I move it into the public cloud? And this really is one of the killer applications of the software-defined perimeter. Nothing on the user changes. You could literally move that application over a weekend. The user leaves on the Friday afternoon, comes back in on the Monday morning, clicks the same link or fires up the same application they've always had in the same place on their desktop, and you as an organization have determined where that workload lives. Nothing for them changes. So the whole point of divorcing network access and the simplification around operations, which is what I described at the very beginning of the presentation here, is designed to satisfy those kinds of requirements. So fundamentally what we've done then is we've taken this whole model of network and we've turned it inside out. So instead of starting with network access and then building a layered approach or perimeter approach to bringing that user into the organization, what I've actually done is I've decoupled you from the network. I'm providing you access to any application in any environment for any user that's federated to the solution from any location. I'm providing that as a consistent experience, so I'm not asking you to change the way you work. Nothing changes on your desktop. I'm also then distributing all of that access and providing visibility across the platform. So no more access control lists that were written 3 years ago that someone asks in an operations review meeting, why have we got that there? And really the only way of figuring it out is to either switch it off and see who complains. And the last bit here is simplified administration. So this is a future thinking comment here. But let's say, for example, you employ zero trust in a software-defined perimeter. And the old way of working is to say, I have to have this change control process that says, I've got a new server here, and then I'm going to step through each of these individual components and configure them so this particular user has access to that particular application. Now look at it from a software-defined perimeter perspective. I know who Ian is. I know the application. I know its location. I have a policy that says Ian is now a member of this group to access that application, and Ian gets access. So you literally reduce 70% of your operational overhead and your support overhead in deploying these kinds of solutions because you simplify that end-to-end process. And that's fundamentally what we're about at Zscaler. It's both the inbound and the outbound, but in terms of the software-defined perimeter, it's that operational control that you can derive. So just to give you a little bit of meat around the bone around what this is used for, there are 4 key application usages for software-defined perimeter. So the first one is application access, and that could be any kind of inbound access to applications, client server. The second one is wherever you're employing multi-cloud access, so that could be the AWSs and the Azures of this world, so to speak. The third is secure third party. So if I'm bringing someone and I'm using the software-defined perimeter to give you access, I'm not necessarily giving you network visibility. That's a significant threat, but usually a smaller number of people in an organization. So I'll come to that in a second. And the last piece here is actually acceleration of mergers and acquisitions, whether that be departmental within an organization or externally. Because remember, what we're not doing is giving you network access. So I fundamentally don't care if I've got a user on 10.0.0.1 accessing an application on 10.0.0.1, it makes no difference. The network connectivity doesn't exist across the software-defined perimeter. So what does this thing on the screen say to me? It says, these are use cases, but the platform you're employing, the thing that does all of this is that ZPA platform. So just to reiterate, what we're able to do then is we are connecting on the right-hand side users to applications without giving network access, authorizing you, segmenting you, and then providing ubiquitous access to those applications. And maybe on another day, we'll talk a little bit more about the internet access piece, which is all the security perimeter controls and capabilities that enable us to secure the outbound access from that device. But for us, as an organization, combining those two functions in ZApp on one device, for example, is what really drives that zero trust discussion. So my recommendation really is, we can easily work with you and Bytes to understand how we go about leveraging software-defined perimeter. The two things that I'd leave you with in terms of, overarching view of this, we've managed to deploy in some customers within an hour and 45 minutes, depending on who's actually involved. Not that I would ever belittle people's change control process, but the point I'm trying to make here is this isn't a long-winded POC process. I don't need to ship you kit. Most of the workloads are already pre-built, and we have a very clean process for proof of concept or testing. And like as not, there's also a series of architects, and workshops that we can run that aren't just focused on us, that will come and sit down and work with yourselves and Bytes to understand the wider implications of zero trust identity and other components. On that note, hopefully today's presentation has been in some way useful, and we certainly look forward to any questions or queries that you may have. Thank you. I guess at this point, hand back over, do I?
Yes, indeed.
Or can you take control?
Your presentation.
Okay, well done, thank you.
Ian, I do have a couple of questions from the audience for you, which is great. Also, if you have any questions, please just take the next few minutes while we answer the first one to drop them into the chat, the questions box, and I will pose them to Ian. And so the first question is from one of the audiences, just asking for a little bit clarification on application attacks. First question is, says, so this method cuts down on network attacks, but would it not increase application attacks?
Not necessarily, no. I appreciate the question. It's very interesting. So first and foremost, this is an access mechanism. It's not actually scanning, interpreting, or storing any of the data about the application inside that access. So for example, I'm not outputting any data streams to a DLP solution or anything inside the brokerage mechanism. So you are quite correct in saying, should a user have a compromise that enables them to transfer, for example, data to a file share, then I would be looking at traditional controls within the application target environment to control that. However, when we apply this in terms of the networking side and the identity provision, it does have a knock-on effect from a policy perspective in controlling these applications and how they are accessed. So if we were to work in a workshop, I would break that down based on a series of different functions and capabilities, but you are quite correct in as much as we are not entirely removing the risk of application-based threats. Thank you.
Thank you. And another similar question, do we not control the machine the user is accessing? If so, can
no. So that's a really good question. Sorry, Yen. In Zero Trust, because a lot of the way in which we might do things like posture checking or controls on a local device derive themselves around those local controls, for example, things like, are you patched to the right level of AV, etc., we still do that. So I still have a posture checking, I can manage certificates, I can do some fairly advanced things on the local device, but all of that feeds back into the identity-driven access model. So I would, for example, still be able to, at one extreme, determine whether it's a corporate-owned device and then manage policy accordingly. At the other end of that spectrum, or the other extreme, I might well be, for example, looking at Android with a user container with ZApp running in it and another container that doesn't. So there are a variety of mechanisms there.
Okay, thank you. I hope that's answered your question. And then a final question here. How does Zscaler deal with centralized printing?
It's exposed as another application. It depends on the data path that's used. So I have 3 different models of this employed at the moment across Europe. I have print services, for example, Canon, HP, and others that are used. I can expose the print server queuing as part of Active Directory, IWA, and other capabilities within a central data center, and or I can directly address the printer natively. So that just looks like another client-server application.
Okay, thank you.
Still there? Yes.
Yes, yeah, I'm just muting in between, so I'm not talking over you or there's a lot of background noise. So thank you very much. I don't have any further questions at this point. Of course, if any questions occur to anyone in the audience post-session, please do forward them to myself. I'm more than happy to forward those on to your Bytes account manager who can liaise with the Zscaler team to make sure any more detailed questions or any queries are answered. Just to reiterate, we have recorded today's session, so I will certainly make that available so you can share the insight with your teams and review it at your leisure. And then lastly, just to thank Ian for his comprehensive presentation, really good, very comprehensive and insightful insight into looking at Zero Trust. And thank you all for coming, and thank you for bearing with us with some of the technical issues we had last week. So I'm just going to close the webinar now. Thank you all for coming, and please do just take a minute at the end to fill in your feedback forms so that we know that we're hitting the right mark on these sessions technically. Thank you very much, everyone.